Assalamu alaikum everyone, I'm your physics teacher for class 8 and this is week number 5, 4th May to 8th May. In this chapter we are going to discuss water pressure in a closed container, Pascal's law and application of Pascal's law. So it's very helpful for all of you guys to understand the practical application. The objective of the video, after studying, students will be able to explain Pascal's law, hydraulic system, gas behave under pressure, describe the causes of gas pressure in a container. Review of last week, because force and pressure are going to be used in this video very much. And force, everybody knows that force is a push and pull. Force can also change the direction of an object and it can also change the size of an object. Pressure, force per unit area. The force acting perpendicularly unit area is called pressure. We have two units of pressures. First one is Pascal, the other one is Newton per meter square. Both we can use, but SI unit is, both are SI unit. And water pressure, and in the previous video we discussed regarding water pressure is that the pressure increase with the depth of the water. If the increase in the depth, water pressure will be increased. And yes, we are going to be start water pressure but in a closed container. The sources which I am going to use in this video is Genescience Punjab textbook board, e-learning website, and e-learning website give me a very good YouTube channel and you can learn your something very new, something very exciting with this YouTube channel. It's for you guys. Liquid pressure in a closed container. Pascal's law. Liquid pressure in a closed container explained by Pascal's, and that is called, its law is called Pascal's law. So what is liquid pressure in a closed container? Liquid pressure in a closed container is equally transmit in all direction. When a pressure applied on a fluid enclosed in a vessel or a container is transmit equally in all direction. This is called Pascal's law. In a previous video we will discuss in water pressure. This is not in a closed container, but now in this lecture we are going to discuss the water pressure in a closed container, and the pressure applied on the container is equally transmit in all direction. If we take a flask equal size of hole and we apply a force with the help of piston, we will see in the application of Pascal's law that equally transmit in all direction. With the help of this concept we will understand some application like brake system, like jack system. We will see this system in normally in our daily life, and it's very important law regarding the very wide application. Hydraulics, the branch of science which deals with the transmission of fluid pressure through pipe as a source of mechanical force, is called hydraulics. The first application of Pascal's law which we are going to discuss in this video is jack system. Jack system is basically a hydraulic system, and we can also say that it's a hydraulic jack. Hydraulic jack system is basically follow your Pascal's law, and Pascal's law said that when the fluid is in a closed container and when you apply a force on it, pressures transmit in equally in all direction. With the help of Pascal's law we explain this jack system. Okay, let me explain in detail what happened with this jack system. This is the oil tank which provide a sufficient liquid which needed to lift up this car. What happened? We apply a force on a small piston which create pressure in water, and by Pascal's law the pressure create in equally transmit in all direction. So the liquid which is here is get the same pressure which the liquid is here. So the number of particles are apply pressure on this large cylinder which create a more force which we are going to apply. That is where this condition is true. The force 1 is less than force 2. It's mean that we are applying a small force and get a large amount of force. In this way we are going to lift up a heavy material. So valve V1 and valve V2 is also to prevent the liquid back in the oil tank, and at the end we have a stopper. So if we have complete our task, so stopper will be open and the liquid back to the tank. Another application of Pascals law is brake system, and first of all we will see the parts of brake system. The parts of system will start with the from right side, and first paddle, then it force transmit to small piston. Small piston are attached with the master cylinder. So you apply a force on the piston and piston is attached with the master cylinder. Your cylinder is attached with the pipe, and that pipe will be attached with the slave cylinder, and the slave cylinder has large piston. It's mean that master cylinder has joined with the small piston and with the paddle which produce pressure, and that slave cylinder is just have to receive pressure. It's mean that it is slave to the masters. Master cylinder is produce more force, more pressure. The most pressure will be received by the slave cylinder. So that is why it is called slave cylinder, and that is why it is called master cylinder. So here we have a large area attached with the pad. It's mean that every water particle have same pressure, which create more force which is applying. And the quantity of force which is applying, let's see F1, and the force which is produced here F2. So it is simply clear that F1 is much less than F2. If we assume that with the help of our leg we are unable to stop the car, but with the help of brake system you are able to stop the car with the help of brake system and with the help of very unique law that is called Pascals law. So this is all over from the brake system. So let's start the working. We apply a force with the help of paddle, small piston, and the pressure is generated in liquid which is transmitted through the pipe and received with the large piston and slave cylinder. So which is applying a large force comparatively to the input. So we got a large force comparatively to the input, and that pad is attached to that disc, and your car, your bus, your bicycle will be stopped. The last topic which we are going to discuss in this chapter is gas pressure. If we have a container and the gas inside it, the gas are continuously in state of random motion in all direction. They haven't a certain direction. So the gas, when you spray in the room, the smell of the spray is moving all direction of the room. So after some time you can feel that smell. We have two points which are going to be discussed in this topic. Is that gas pressure will be increased if we decrease the volume of a container. Let's suppose we have a container like this. You can see my cursor. We have a container like this. We have a number of gas particle in it. They are in random motion. So now we reduce the volume of particular container. It means that gas pressure will be increased. So it means that if we have to increase the pressure, so decrease that particular container or area of the container, volume of the container, you can say that. So in that the area, the pressure will be increased. The second is that the gas pressure is also increased by adding more gas in the container. Let's suppose this is your container, a gas inside it, and you want to increase the pressure in it. So what will you do? You just put more gas inside it, more gas inside it. The more gas, the more coolant, the more pressure inside it. So this is all about the gas pressure. Let's summarize our video. In this video we learn about liquid pressure in a closed container, and then we talk about Pascal's law, because Pascal explained this concept. And moving on with the application of Pascal's law. In this we study jack system, how jack system work, parts of a jack system, and then we talk about brake systems, how brake system is work. We have a different type of brake system, and pressure brake and the liquid brake, oil brake. So we just talk about the working of the jack brake system, and let's move on with the gas pressure and how gas pressure increase or decrease in a closed container. This is the very short summary of our video.